Do you have all data now? Do you have them all? Well, we are going to start. I'm going to show you, let's say, an example of a process. We're going to program what you have been doing, well, used, I mean. And once we have the first steps, then we will make it more complex. That depends on the time we have. Well, to start with, I would like to tell you where you can find documents about the script module. So if you focus on gvSIG org, then you can get into the page. Do you know the Wi-Fi? It's going a bit slow here. And I'm going to show that, and then you have. I don't know if in the future we're going to upload all the material and the scripting course. And you until Sunday you can register in the course. Once you get into this web page, then you can get through documents of the user in this main page. It's a bit slow, yes. Anyway, it's very important that you have here the reference guide. Here, manuals and guides. And here you have information about the scripting module, and here you have the reference guide. So this is very useful in order to know which are the main methods used by gvSIG, and you will be able to check the data. Here you can open that with the portal. I'm going to have it open in order to explain to you different things. I have the reference guide which is translated. I'll share that with you. The reference guide is that we teach the classes that you have at gvSIG. This is our part of the project. The way of having access to our project, to our views and to our tables and so on. And what is not here is the functions that the utilities that we can use. For instance, here we can have access to views and we can have access to get view in order to have access to that view. And here we have that summarized. So this is a little bit an overview for you to know. So you open gvSIG. We are going to create a new view, and we are going to add the apple layer I told you about. You come here to the project manager, and then you go to properties, and you look 32630, which is the layer that I am putting here. And simply here you have MPSG, and you have to look for it. You have to search the code 32630. 32630. I don't want to modify anything. And then you click in apply and OK. If you have any problems, please ask Joaquin, because I don't want you to get lost with those cases. So here we go to the icon adding a layer, and then we look for the layer. Doesn't matter where it is, and something like this should appear. So if you have them loaded, you can, if you have other layers loaded, you can just remove them, because we're going to use only this one. And in order to have an easy access, if you are in Linux, I'm speaking for Windows, you can create here something which is called a taller. You can create a taller, and you can also create I know where is easier for you, because here we are going to create the present layers, so the new results will appear here. And with this we are going to do the programming. First of all, we're going to work in a randomized layer. I have used that very much, and when you are in the scripting module, then you're going to make many mistakes, and it is better to work on layers that can not make damage your work. The way of creating these layers is going to tools, then processes, then toolkit or tool box, and here if you write alia, that appears because it's randomized in Spanish, alea, aleatorio. If you have any doubts, please let me know, because then we'll save time. If you put alea, then you will have a process in which we have the aleatory, so that generates a new layer. And it's very good when you have to do tests. Then we open this, we select for instance 10 geometries. Well, you can put 20 of dot type, and in output then you create a folder in Linux or wherever you want, and here, and you put a name. My name is capa de puntos 01, so dot layer. So this is your base layer. Then you tell us which is the view that you want. We have a title here, and as you see, we have a series of dots in the extension of our layer, the one that we had open, and we're going to work on this layer that we have just created. The good thing is that you can work without any fear. You can generate polygons, anything you want. Then perhaps I shouldn't do that, but well, when you open a geoprocess, then you have analysis, then it says take extension of another layer, and here you should have your apple layer. Then you select the apples layer, and you click, and it should work. Then it was done by default, and the only thing it does is that it generates dots in that area. And then I was selecting this dots area. This is very important because in many of my scripts I work with the active layer. You can work in other ways. If you have the scripts ready, then it's very simple because then you just execute the script and that's all. So it's important that you have this selected. And now we're going to program. And then we go to the script and composing. And then we can have the scripts, and I have many of them. You will have this empty probably, and we are going to create a new one. First of all, we are going to create a new folder. Click new, and then we can add a scripting workshop. We are going to say you add folder, and then you say accept, and here you have a new folder. I recommend that you that better than myself, because if not you will end up having things like this and you lose scripts. Well, it was not difficult. And then we're going to create the script that we're going to do, and we're going to put a buffer here. So if anybody doesn't know, a buffer is an influence area around a dot, so when we create polygons, and this is the influence area around that dot, and we can specify which is the radio distance of that. So we are writing in the name of a script and Python language. That should be by default, and then you do click and accept, and then you would have there are other languages that you know are more useful. I didn't try them, but I could like I work with Python because it's simple, and that works very well. The rest I didn't have the opportunity to try it, and that could be a script which is completely valid. I don't think I don't think I can do that larger. can you ask if they can switch off the lights so that we can better see the screen? Better? Do you see that at the end? Do you see that better? If you can if you can work with the internet, then I'm going to send you the code, and you can just copy and paste. But if you are lost or something is not working, then here I'll put that here, this here directly, and you only have to copy and paste. Then this page should appear. And I'll try to stick it. I have that open again. Always, whenever you modify a script, remember to go to save and then go to the well. You can do that with Control S and F5 to execute it. And you can do that. And here you should have a wall globe. Then you see the structure of the script. You have to import the libraries that we are using in gvSIG. We have 4 libraries. The one of gvSIG, the geom with the geometries, dialog for pop-up windows, and the raster in order to process rasters. And here we are having access to gvSIG. Right from input, we are saying that the library geometries, we should import everything we have. And then we would have that completely loaded, and we can work with it. When I do some modification, then you see that with an asterisk, that means that all changes are not saved. So you should always check that asterisk in order to see that it is saved, especially the code. And now we are going to start to do the programming. Simply, you should remember that we have this layer which is selected, is the dot layer, and then we are going to access data and see which are the data contained in that layer. We have a Warren layer command that refers to the active layers. In the reference guide, then I have this in format with colors and so on. I know. I think you can copy and paste. The reference guide, there are different places where you can consult it. It's in Spanish. If anybody finds any mistakes, then please let me know. It's also in English in the link that we have just posted. Well, I do not want to get into much detail. So, in the reference guide, useful functions. As we can see, one of them is the warrant layer that is returning as the active layer. That's being done by the layer, which is of the type layer kappa. And I mean that knowing that we have a layer, then we know that here we have the layers, and we can apply on them all these methods. We can have access to the entities, we can add new ones. So this is the way of using reference guide. If you know how to program, this is really obvious. But for those who doesn't know how to do that, then well, it's clear. For instance, one of the commands that appears here is in order to ask which is the type of layer. For instance, we can do a print layer to get a vector type layer, and then we should put name. We are asking for the name. If we execute that and save it, then we see point 2D saying that this is a dot layer in 2 dimensions, and here we're going to make it more complex. What can we do now? We can have access to the entities of this layer. The entities of this layer are, if you come here, they refer to the information of our layer. So then here, those would be the entities, and that refers to the dots that we have here. If we do to the scripting, then this is with the features method, and we can save them, and we say have access to the entities, and then we will have a command with a group of entities, and here we can iterate on them. Then we can go one to one over them. So a for is a loop. This iteration things, we can repeat things as far as we have a group of entities. We are going to iterate on them. Then for feature, and then futures. Excuse me. So then we what we are saying is copy this identity within those identities. In Python, after a core, there are no kinds of brackets and things like that. Here we have indentation, and they should be at the same level. So what we can do is, depending on how you are iterating within all these entities, you should show the fill. And if we do a click in save, then we see that we have the IDs of this layer. That would be the basis in order to have access to data. We would be having access to our entities. If you have more fields, then that could appear, and with that we should treat that. This is a number, and we could work on this. what we should do is to carry out a buffer, and we have to go farthest away. As the buffer is of the polygon type, we'll need a new layer. This is a dot layer to a new layer which is of the polygon type, because these are the influence areas. I don't want to get lost. We are going to see where we want to house this. This is what we have created, and here we have we put the name buffer 01 save. With that, we indicate the name of the layer that we want to create. Another thing that we need is projection. How can we have access to the projection once we know that we have to put that in the same projection of this view? And then we have the class view. So it should be the PDF. This is the same, but it's only in English. But it's exactly the same thing. It's not loading. I think the internet is not working very well. If you go down, all of them should appear, and it's basically the same thing as the PDF. In the PDF, I have translated that into Spanish because I did that for my end of course project. You are going to consult it very much, and I think it's more or less clear. This is the one I want to upload with colors in order to know in which library is each of them. And that refers to dialog library. The second part is gvSIG library. And we have the vectorial, which also belongs to gvSIG, and the geometries, which is in green. And I'll send that what is in the web page. But it's the same thing that appears in the web page. The only thing is a little bit more tidy. The other thing we know is the projection that we are using in the view. We have to indicate which is the type of projection that they need. For this, we are asking for CRS that refers to the projection, and then we ask Warren view, which is very similar to Warren layer. And this is the command which is get projection. If and with this we would ask we would have the projection here. That means that this is not what we have in this view. Another thing we need is the scheme. The scheme refers, if we go to the attribute then, that refers to the fields, ID fields, and the structure that would be. And as far as this is a shape, even if it doesn't appear here, is a field which is of the geometry type. So what are we going to do? We are going to create the new layer with the data structure of this layer that has just been created. The way of doing that is get schema, and then you ask which schema to the layer. Always when I put this kind, I always have a reference guide, and it is also very important the extra information and the type of object that returns to you. And for you to understand this is more or less and based on this scheme we can create a new scheme, and then we create that based on the previous scheme copying in the page. And I'm not sure. I think we should use Unicode. You should put the percentage sign with an S, I think. And also very important, when you write the road in Python, try to avoid the spaces because they can give you problems. And even if it looks a very small thing, you should use the bar. If you use the counter bar, then what happens is that this value, which is bar t in Python, that means tab. As far as this is a chain of text, we are inserting tabs, so it will be wrong. If we put that, you have to put a double bar. Is that the same thing? It looks like this is a very simple thing, and then you put counter bar, and then Python doesn't understand that path. So the following step is creating the new layer. We have to create with this scheme. This is a scheme which is created. We can modify this. We can modify existing, and then we have a new scheme which is called distance. The append command. In the reference guide, this is used to aggregate a new field, and here we put distance, comma. Then we should indicate the type. So all these kind of parameters, they appear in the reference guide. The kind of parameters that you have to do, and the size. We can put size equal to 10. So what we are doing is to modify the structure of the layer, adding new fields that we can use, and finally then we can create the layer. We can create output, create shape, and we write the scheme. We write the road, the CRS, and then the type of geometry that it's going to be our new layer, geometry type, and then we put polygon. this is from 0. We can put polygon, and here that appears in the geometry. And with this, we are creating our new layer. Then we can add this to our list Warren view. We access and this is in order to load the different layers that we have created. We have output that shouldn't give any problems with this. We are putting again, then I'm going to check this and then we execute. That's not giving any problems, and we have created and we are creating our new layer with that, and then the buffer is what we are going to do now. Polygon. I had no error. So yes, that's it. This is a real number. This is the long of Python. This is we could also put the integer for whole numbers, also text extreme, Boolean. For the fields which are just true or false. These fields appear in the guide of the developer. The developer guide, sorry, because internet is not going well, but here we have the developer. I cannot take it, I cannot do anything wrong, and here you have the information, among which you have all the fields supported by gvSIG, and now we know that we can create our layer without any problems. I do not want to make things more difficult, and from now onwards, if I want to execute the same script, it's going to give me an error, and this is really complex. You know, here I have the other layers, so you always have to select the layer in which you want to work. So if we execute this and it's not giving an error, so very often it's going to give you errors, and this is because it's empty. And this is because you have a layer with that name. And always whenever we are in the script, we are going to go to the road or the pathway, and then you have to use one or two. I use a while in order to check whether this layer exists, and in case it exists, then it adds +1 at the end. And this is not recommended for the final script, but while you are testing, that's very convenient, because then you can make any trial and test you want. You should not be afraid of launching your script. If you know that it's not working, if you launch it, you will receive a message stating which is the error number. What we are going to do now, we are going to introduce those areas of influence in this new layer that we have created. each time that we execute a script, we are creating a new layer. We are not working on the layer that we have created each time that the script is launched. Is a new layer. How can we do that? We can have access as in the same way as we have had access to the ID layer. Then what we want to do is we leave the output for the end because when we are finished editing the layer and adding all data to the layer, then we add that to the view. And here in the middle, you can create your for and for features and features. Is that all right? Then we're going to do something similar to the previous thing. The only thing is that what we are going to do now is to have access to data and modify the geometry. The geometry is of the dot type. How are we doing that? First of all, we have access to data. We put values. We type values here, and we tell that this is going to be features get values. With that, what we are doing is to have access to all data of that layer, of that entity. Inside that's iterating entity by entity. So then, in these values, that referring to the ID and geometry of each point, what we want to do is to modify that geometry. How do we do that? We have access to this. We access to the value of the geometry, which is stored here. Then we access to the geometry value, and then this geometry is going to be modified. We have a geometry of the dot type, and we are going to transform that into an influence area. In order to generate this, we put feature geometry. If we would leave that like that, we would be having access to the dot layer. But you should be careful, because if we leave that as it is, when trying to introduce a point geometry, it's not giving you errors, but when you try to save that layer, it's giving you error, because it will not be able to store that in a polygon type layer, because the initial one was a dot type geometry, and now we are going to transform it into an influence area. In order to do that, please say buffer, and what we are doing here is to apply a buffer on that geometry, and we are applying a 50 meters on this geometry. If you go to the reference guide, this green part at the end, which is the geometry department, we are having access to the dot, and you could see all data contained here. For instance, in the initial script that we have been doing, for instance, if you want to do test, then you can put a return, and then when the execution of the script reaches that point, it will stop. And here it's just for you to see. We have access to geometry, and you have the X and the Y fields. If we see that then the X coordinate and the Y coordinate is very simple. You are having access to your data in a way which are three lines. These data are they can be useful you can record it in a text and putting your code in order to send it through email. So with just 3 lines, you are sending an email to your worker in the field that asks you for the coordinates of a given point. And we are doing that with a double click on your script. There are many applications. And the problem is, I don't know what are you going to use that for, and this is your responsibility, looking for the best way of adapting this to what you need. So here you have the values with the geometry which has been modified, and what we want to do is that this entity which is modified is added to the layer that has been just created. We have output open values. This can be done quickly because we are using the same structure of data of the previous. We have here the data structure. Here we have 2 of them, and the values of this entity coincide with the new one, and we can add this with this line. We are adding the line and the geometry which has been modified in the influence area, and here we have output out of the 4. That was what I was mentioning about indentation in Python. If you don't put the spaces, is out of this lookup, then you need different brackets. With Python is much more easy, and you should do that with 4 spaces, always with 4 spaces, which are 2 tabs. If you are doing that in another language. So what we are doing now is once we have all these entities in the buffer layer, then we are going to save that. We are going to save that layer. Then we do output. And with that, we should save that. And as we did, we are adding this to the view. And if everything goes all right, then we execute. We see there was no errors, and then the first geoprocess appears here. I am going to copy that in the page if you are lost for any reason. Now it's full, and it's very easy. I put 50. The projection is UTM, so it's taking that in meters. See, if it's in degrees, then it takes degrees. It takes degrees. I don't know if we should look if the projection is WGS, then perhaps you should convert that into meters. That's it. we should see you should put quadrant layer. I think it's the same thing. This method is the same for both of them. Warren view or Warren layer, even to the project, the projection of the final project. Send me an email and we can check it because I want you to look at those things, because sometimes I don't know how do you use that. Everybody is all right? Are you trying with the code? Is it working? It shouldn't give you any problems in this part. Java error? Java error? But it is appearing in the console. Did you copy and paste from mine? I don't know if I copied that all right. The road, are you in Linux? The road you will have to modify it. You will have to remove C colon, 2 dots. And in order to program in Linux and Windows, the only difference would be the pathways. Anybody has erased that? We can put that again. Because this is shared, and unless anybody, and if anybody is erasing it, then it's erased for everybody. Here, you have that complete. Yes, and the apple. The one of apples, we are not only doing the one with apple, we are also doing the dots one. It's so in fact this is a due process. It has no additional complications, and this is directly very useful because here, for instance, intermediate data, which is the distance of the buffer, we are not even limited to a fixed distance or a variable distance that depends on any of the fields, but we can also introduce more complex functions like distance to a different geometry, distance to another layer, and so we can do many things. We can modify the buffer as much as we need. The good thing regarding the geoprocesses is that we can introduce different conditions for many different layers. That means now I'll try to reach the end of it, and after we will check that the buffer is only created in the intersection, because that could be a condition. But this could also be another condition if we have an intersection with other layers that checks in a different layer that the distance to a hospital is more than 100 meters. This is the good thing, that we can create a geoprocess that is just adapted to our needs, and we do not need 1,000 intermediate steps that we should do with more traditional geoprocesses. That we would have to execute different processes, gather them together with a spatial joint, put different filters. With that, we do exactly what we want to do. If that works, then we're going to continue. we are going to use the distance field that we have created. We're going to do a use of it. What I'm going to do is at the same time that it is creating the buffers, it should indicate the distance to a point I'm going to introduce on this area, on this spike in the apple layers. For instance, in order to start with, we are simply going to create that point, ref point. The way of creating this is just creating a geometry with those coordinates. And in this way we have a geometry that can be compared to the other geometries in a very similar way in which we have used the buffer. Here we have ref point and we create a white dot, which is create dot or point. And then we have ref point, set x, and we would be introducing the coordinates. As you may see, if you go to the reference guide, here you have the point, create point, which indicates the way of creating it, and these parameters between brackets, that means that they are optional, that in order for them to work you don't have to put them there. This is the case we are creating x and y subtype and we're creating white. With this create point, what we are doing is a return point. That means that is returning a geometry of dot type. Here we know that we have a geometry of the dot type. We can go to the section of geometries of the dot type. Here we have serve x, serve y in order to indicate those values. It's the same thing that we did before when we were asking the values of x and y, but now what we are going is inputting those values. We have 725,000 and the y is on 4,370,000. With this, we are creating a point in those coordinates. That's simply, I came here and I watched one that was in the area. There is a reference and we can take that from a different layer. So I did the spatial analysis, and what we are doing is to take another layer and we are applying a much more complex filter. So please tell me which point is the closest, the farthest, and so on. This is for the calculation of roads, approximate roads, and so on. As I told you, we are creating a reference point here, and we are going to introduce something each time that we create this buffer that calculates the distance to this reference point. And as I mentioned, what we are doing is to modify the buffer geoprocess. We are not adding another geoprocess. That could be the traditional way of doing it. Adding a new geoprocess, sometimes I have to work with layers having 150,000 points. Then when you launch different serial processes, then you cannot work because you have problems in the memory, problems in time. So I need a process that is adapted to my personal needs. That saves you a lot of processing time. What I do sometimes, it takes 12 hours processing data. If you do that with a series of geo processes, which is a model builder type, I could be working for 1 week, and probably I could not even do it. you can also create a line, create a polygon, and how it is working. And as I said, we are modifying geoprocess. There is a value that refers to the distance, which is being left in blank, so we are having access. Is having access to this distance field, which was before white, and now we are going to ask to ask it to calculate the distance. We do that having access to the geometry, which I remind you is the one belonging to each of the points. We are working on the resulting layer. We are having access to that geometry, and now we are saying please calculate the distance to this reference point. If we say modify this name from the road, because if not it's going to give us error, we are going to save, and then we execute. Error. I don't know why we got an error. Okay. Yeah, I see. So there was an error when introducing the numbers, as far as it was between inverted commas, and then the Python takes it as a text type. This could be done if I'm not wrong. With this, a text change becomes a whole number. This is very interesting, especially if you have fields which are text and you want to convert them into numbers. You can do that, or if you take data from a CSV, you can convert that into numbers, and you can use double. You would be converting those data of the text type, and we remove the inverted commas, and here we would be introducing this and that would be a number type. Well, this is a little bit laborious. We are checking that we are on the results layer. We execute, and here we have the new buffer type. And if we access to attributes, then here we have the distances. If we want to see that better, right click properties, category, symbology, quantities, intervals, and we use distance. Then we say calculate intervals between these distance values that we have just created, and if we push accept, create and accept, based on this distance field, they are increasing as we are farther from this point. That is just to check that we are taking distances currently. This is a lot, and you would have to adapt it to your needs. And we can continue with this script. And another condition that we can introduce is I'm going to give to copy that in the page. Here you have that in the page. Now we are going to introduce an additional condition. This condition is going to be that if the dot has an intersection with any of these apples, if there is an intersection, the program should create that, but if there is no intersection, I don't want to create that. This is another condition inside our loop. First of all, we have to have access to this layer. Please have access to layers. I am not doing it right, so you should have this space unexplained, because if not you would get lost, and if you check that after 3 months, if you do not have the explanations, then you will get lost. The way of having access to this layer, the way of doing that, we can have access to Warren view. I'm having access to this view, and then we will have access to our layer with the command get layers, and we have to introduce the name, the precise name that appears in our view. Depending on how you add this, then you can put apple dot shape or apples Valencia. Now it doesn't appear in my case, but you need the precise name, which is written here. Here is apples or manzanas barra baja Valencia, or apples low bar Valencia, between inverted commas, because it's a string, it's a text, and we are having access to our layer, apples. So the condition that we have to ask is always, before adding this value to the new layer, first check whether this is intersecting with our apple layer. And how are we going to do this? We are introducing another for, and we are doing to do the same thing. So with entity, for each entity we have to check whether this intersects with any of the apples. So these are different loops, and for each entity we have to execute one complete loop. Here we have a fourth in a layer. With features. And this is features because here we had access. It is a synonym. So these steps you can skip them, and you could put here the previous things. Warren view, get layer, this kind. We could put that in this way. It is the same thing. So I'm going to put that in this form, in this way. And we could be putting that inside this, and the only thing we can do is whether this dot intersects with any of the apples. The way of doing that is introducing a conditional, an if, and what we write here is if this dot, if the geometry of this point intersects with the geometry of the apple, then you execute what is here inside. Okay? And we have to introduce, first of all, the intersect commands. This intersect command, you can find them in the reference guide. These are the functions appearing here. These are the geometric methods which are of the polygon type. We can ask for the area, whether if this is buffer, the centroid of this geometry was done before, and we can find more of them in geometry 2. Here in the reference guide, you have the geometry Java 2, which is leading you to this page, and you can find many more methods. As you see, if we go down a bit, then we have the intersect method, and this is applied over a different geometry. And we have a geometry. We have a geometry, and we are asking whether this intersects with any other. As you see, what it returns. This is true or false. This is like a variant of the number type. This can only contain true or false. It's a Boolean. 1. So we are asking whether this intersects. If it intersects, it could return a value of true. And this could be a true condition, and they would not execute because we are telling if there is an intersection, it should add the values. If not, it shouldn't add the values. What the brick does is that once you have added the fields, that the execution is stopped, the execution of this code. We can only do the access with very big layers. Why should we iterate? So it could be a way of leaving this for. If we save this. You execute intersects int error. This is the error that you usually have when you do not modify the can finish layer edition. That means that you have created it, but there is already a layer that exists with the same name. Then you have to modify the name execute, and then you see that there is no error anymore. And then we go here, you see that it has created a new layer with these buffers, and as we can see, we have some buffers missing that corresponds to those which are out. So that intersects with the Apple layer, and it has not created this. We can do that through geoprocesses, but then you are skipping some, so that's going to save a lot of space and a lot of time of geoprocess. With you can write you can write any comments. You can follow the line. This is so. Python is ignoring that. It is also well, I suggest you that you create other functions, because you could create other functions. For instance, an addition function. If you have a function outside, if I'm not wrong, to define this function, then you should explain this is an addition. What it makes is adding things. Correct me. But in some of the guides, then you see. This is a way that the code is beautiful to say it in a way. And the comments should be put at the end of the line, especially if you are lost. Because if not, it would be too long and you could not understand it. So if you put east, then it ignores it. No, as far as I know, no. If you want to create a text that has inverted commas, then you should say this is a sentence, for instance. And in order to do that, you should do that. So you could be taking a text and the triple commas. Any fault, because the important thing is the failures. Here you have. The Linux, you have to change the road. Then if you have developers, from the scripting module, it should import each library. We can have access to the Java libraries. We can have access to everything, and that allows For instance, the grant I did that was a course in order to have access to the gvSIG processes. I did everything with Python. I even didn't have to learn Java. So I only needed to understand the things which were written in Java, but all the rest I could do it just with Python. So we are focusing the user and all the things that are prepared for Python, and you can have access to the whole Java that you have. So this can be very easy instead of making things more complex with Java, and you have to do that from this module. To follow this, we can do another script. We have half an hour left. What we are doing in the following script is doing a union. So we are going to create a line that is connecting all those points. So we leave it here open. We have the new script, the new line. I'm going to send you one thing. You don't have to do that. If you put here type dialog, is in order to create a script with a window with a graphical option. As you see here, we can create windows, the text combos, buttons. We can create buttons. For instance, look, see, the ID of a field. The ID, this is value 5, and we can do the configuration and then do a search. For instance, this is a possible script with 2 buttons and many other things that you don't have. Then I can do a search with plugins. This is really powerful, and you could make everything more or less complex. I think that my blog, I have a script of this type which is published in order to open PDFs, and is based in, let's say that all entities that we have here. One of the fields had a link of the PDF that could be very useful in the cadastre, for instance, that would give you the name of the plot 2.5 PDF. And what I was doing is that when you were pushing the button search, it went to a folder and it was doing a search in all folders. Trying to look for that file, and if it could find it, it was open in gvSIG. That can be very useful. I think there are images that can also be open in gvSIG, and that can be used for anything. That saves a lot of time. That was a question from somebody working in a civil servant, and he was opening the ID, and that was opening the geometry, and that was enough. And then he could see the PDF in order to see if that entity had a PDF with information about it, and it was open in gvSIG. We have created 2 lines, a tool that is fulfilling the function, and we would only need 5 clicks to open such a PDF. So that can save a lot of time, a lot of time. And here we have different tags apart from the code. For instance, in Action, I think introduce the function, for instance, and it could be add. I have to check it. I don't remember how it was. I usually, but it could be like this, and we would be saying that this function is not being executed, and this function should be defined here. Add, and although we are doing a print 5, so I'm going to try this. I think that was wrong. When this is open, we could put that much easier, much better. We can specify the length and with the button print one number. We could do many things. We could include combos, putting all the layers, and then a combo. There are so many possibilities. This is a very useful tool. Here, system, user. Here we have some examples. And in dialogues, menu buttons. See. This is a code. You have the Python, the icon of Python, and this one, it appears on a window. Here you have the code, the different functions which are executed, and here you have the same thing as before. In Action, then we have the function which is executed. I'm going very fast, but this is just for you to see that there is much more information about that. If you do a search which is finlet, I don't remember exactly, finlet, information about how everything is working, the dialogue thing. I usually don't use that. Basically, this is a visual C, the way of putting the windows and so on. There were many years ago where I was working with that, but I just want you to know that graphic interfaces can be done. Here in the X, it's closing the script. I'm just going to leave the one before, but it's not removed. I don't recommend you to erase any script because you will only need a part of the code, or you can erase a part that you don't need, but they are very useful. A new script, a script line, for instance. I want to leave some time for questions. I don't do that usually in this form. When you open that, you have here code and properties, and if you click in properties, you should have that information. I don't do that in this way because I prefer to open 10 scripts and I read what is here. That's why I was mentioning line. And I usually do that in this way, so then whatever happens. So this is easier because without changing the screen, you can always check until and you can read them until you find the one you want. In the properties, you can indicate many more data. If you do bigger scripts, then I usually put something like in, referring what do I need, for instance, an active layer, an out. This is a way of explaining the script, the entry parameters. I was learning. I was a self learning person. I was learning by myself, but those who are doing the mock course, and then I'm trying to explain that what the gvSIG commands are, so that whenever you finish, then you can get into any of the Python courses. You can learn Python, and then you can come to gvSIG because once you do Python, then you will be able to do that directly. In a very quick way, we can create a line that gathers together all the points. A way we have access to our active layer, which is the one of results. We are creating a new geometry of the line type, an empty geometry. What we are going to do is to have access to all the entities of this layer of results. We are going to have access to the geometry. With this geometry, what we are going to do, something that we have to explain is that a geometry of the line type it has many vertices. To create a new line is sending vertices, maintaining the line. So what we are going to do is to have access to all the points, and we are going to send them to a geometry of the line type. I do not recommend to put geom. So we put this line vertex. At vertex appears in the reference line. And then I say that it should introduce the geometry that we just had. And for instance, I don't know exactly what is going to be the result what we are referring to a line in which we have added all the vortexes of the results. So the geometry library is not imported with the geom import all. We are going to save and here we will be checking that we have a geometry of the line type. So that let's takes it to the format which I think is universal to some geometries, is very common, and here it shows all the points that we have added. It could be a way to check that it contains this line. So as you see, it all the points appear here. And perhaps what I could do is to add this line to a new layer, as we did before. With that, we could reuse the code. We could copy this part of the code that refers to everything we need in order to create a new layer. And we paste that here, and we are creating them, the values. Get values to have some reference values, and we have to create a line in the type of geometry line. This we should remove it, and we should add here the scheme. It would not be necessary. We're not going to use that. We would change the name. To this new layer, we add the values. I'm going a bit faster. And to these values, we add the new line that has been created. This is just an entity, so that it takes the geometry that we have just created, and we add this to the layer. And if it works, we have created this, but we did not add this to the view. We're in view at layer. We add this new layer that we have just created. We change the name, and it is in red because we didn't save it. We would need the output line, and we would have this in addition mode. And it is gathering together all these points which are randomized. For instance, in a very quick way, that we could adapt this script, we could launch it on this layer, the buffer layer, that contain the distances. With that, I can show you. I am trying to show you that we can modify scripts and adapt them to anything we may have. You have that copy. Then I publish the code. Everything that we are doing, I'll publish it. Okay. and we're going to adapt this script to the layer. As initial layer, we have to think that we have a polygon layer. So what happens that the geometry is of the polygon type, so to that line we cannot add a complete polygon. The way of doing that is ask for the centroid of this polygon. We are reconverting these buffers in a point, and then we would be adding this to a line. And with that change it should work. Then that already existed in this layer, and we are modifying this. We have created that, and finally that works again. And it's taking the centroid of these polygons. An intermediate stage will not have time to do that. So it could be more or less that thing. Then we would be asking the layer that you are taking, is that of the dot type or of the polygon type, and depending on the type, then you can take the full geometry or its centroid, and we can launch that in any layer without having to consider which type of layer it is. And then that have created this, and then we are going to do that order of points to take it depending on the distances. The way of doing that is in the entities. Then we can order that following depending on the field, and when we ask for the entities, then we order that by means of the distance. Then you see how it can do a better itinerary. So depending on the change of distance, it couldn't be randomized as in previous case, but it would be depending on the distances. It could be the uses. I'm going to copy the last one, so you see that with very few changes you can do many things, and as an introduction, the scripting course, which is for free online, you can register. You still have time to do that, and I have created that in my end of course project, and what you have seen is the end of the course, and I'm going to explain line by line the different things from commands such as making an addition or a subtraction, and this is a bit everything. Thank you very much. I'll post everything. I'll upload everything. Do you have it copy? Do you want to say something to finish this? A few words? You have to say something. Well, this is the end of this meeting. We hope that you were happy with this. Sorry, but the sound is not reaching the booth, so I cannot really. I do not get the sound, so I can't translate. Decidle que abra un micrófono, por favor.